Hello guys, welcome to this video on the TRIZ principle of inversion. So TRIZ is a methodology which is used to perform systematic innovation or systematic problem solving technique, which is used by many companies to come up with innovations and patentable products. So TRIZ is basically a methodology which sets out 40 principles which are very general principles which can be applied to different types of problem statements. So basically you have a contradiction where there are two parameters which are conflicting each other, and you use the TRIZ principle to overcome that contradiction, and one of that TRIZ principle is inversion. So let us see what is inversion about with plenty of examples. So solving a problem by considering the opposite of what is normally expected, or by reversing the roles or actions typically associated with the process or situation or a product feature. So let's say if you're having a product and if it's performing a function. Now if you are inverting that function and making use of that function to perform any other purpose, then that is inversion. Making a movable object stationary, or making a stationary object movable, or overturning an object upside down, changing the orientation of the object to its opposite, or whatever it might be. The inversion is a concept which can be used in many ways, many different situations. One of the best examples and complex examples of inversion is regenerative braking. So braking in general, it is a function which is used to stop a vehicle. Generally, the kinetic energy of the vehicle is dissipated as heat in the braking system. Now what if you convert that kinetic energy back into electrical energy? So you are doing something in reverse. Generally the electrical energy is converted to mechanical energy, which is nothing but the kinetic energy, and then you are converting back the kinetic energy into electrical energy. So this is the concept of inversion in regenerative braking. So instead of dissipating that kinetic energy of the vehicle as heat in traditional braking system, you are converting it back into electrical energy. So the way it works is that the driver applies the brakes, the electric motor running the vehicle. So this is only applicable for vehicles which are run by electric motors, not for the traditional ICE, internal combustion based engines. So when the driver applies the brakes, the electric motor running the vehicle operates in reverse as a generator. So the motor, when it operates in reverse, is called as a generator. A motor uses electrical energy and outputs mechanical energy. A generator gets the input as mechanical energy and outputs electrical energy. So when the braking force is applied, when the driver applies the brakes, the electric motor runs as a generator in reverse. The braking force generated in the process not only slows down the vehicle, of course the braking force will slow down the vehicle, but also enable the motor to convert that that kinetic energy, the mechanical energy, into electrical energy, because it is acting as a generator. Then that electrical energy is stored in the vehicle's battery, and then again it is used for powering the motor, again from converting back from electrical energy to mechanical energy. So this is the concept of inversion which is taking place in the regenerative braking system. The motor acting as a generator, which is inversion of the function, the general function of the motor. Inversion as a principle is actually very commonly used in mechanical systems design. Here is an example of inverted pendulum balancing system. So inverted pendulum system, which is used in balancing robots, places the center of mass above the pivot point, and control systems are designed or are used to maintain the balance of a system by continuously adjusting the forces which are being applied. So we consider the pendulum to be in the opposite direction, that is oscillating based on gravity, which is normally seen in clocks. But if you're having an inverted pendulum, we can use it as a balancing system. So this is a concept of inversion. Also, another simple example of inversion in action is reversing hydraulic cylinders. In traditional hydraulic cylinders, we consider the cylinder, the outer cylinder, to be fixed, to be stationary, and the inside rod and piston to move. But what if we are moving the cylinder, whereas we are making the piston and rod stationary? So this is again a concept of inversion which is being applied. In general mechanisms, inversion is a very common principle which is applied. Here is an inverted slider crank mechanism. In a typical slider crank mechanism, The input is the crank rotation and the output is a slider which moves linearly. So here is the crank rotation, which is the input, and the slider moves linear fashion. It is the output. In an inverted slider crank mechanism, the slider moves as an input and the output is given as the rotation of the crank. So we can say that inversion is happening between an engine and an air compressor. In engine, the piston is moved down. So the motion of the piston causes the rotation of the crankshaft. Whereas in the air compressor, the rotation of the crankshaft causes the motion of the piston, which in turn compresses the air. So engine and air compressor are inversions. There are many such examples of inverted mechanisms like four-barreling mechanism, Geneva mechanism, cam mechanisms, rack and pinion mechanisms, all have their inverted forms. Another very simple and intuitive example of inversion, how inversion has been used in product design, is treadmill. So instead of moving forward while walking, we make the tread move. That is the ground on which we are walking, we make that move. We walk or run in place. We do not actually locomote. We walk, but we stay in the same place.